Thank you so much. First, I would like to thank you all for the warm welcome that I've received here in Thessaloniki. It's been 3 years since I've been here, and I appreciate all that you do to make us feel here at home, coming from outside of the country. I have my wife, Karen, with me, and my colleagues, Drs. Selena Wang and Dr. Louise Ferguson, who you'll hear from later. And we just feel quite at home here in Thessaloniki and at the American Farm School. Secondly, I would like to thank you for putting on this conference, and I congratulate you for bringing together the producers and the growers, the importers, the exporters. And it really is the secret with what we do at the UC Davis Olive Center is to bring all these elements of the industry together, because really holistically all of us are what are required to make this industry work. And it's the secret of our success is the power that you get in this network of people working together. It's not that everybody necessarily agrees with everybody else in the network, but we come together on issues of common benefit, and by working together, we're able to achieve more things. So today, I'd like to talk about a broad issue that the organizers asked me to focus on this today, and that is climate change and the challenges that we have in adapting to it. And you'll hear from me about a broad view of this issue. I'm going to look at the Mediterranean primarily and its impact on olive growers. And then after me, you'll be hearing about a case study on Kalamata and what they're doing to adapt. But I'd like to just start with a broader view, and I've got some really interesting maps to show you of the region, some modeling that we have of the region. So let's see if I'll just use the keyboard. So the first thing I'd like to do is show you this climate modeling, which has gotten more sophisticated over the years in trying to predict the future. And of course, we can't exactly predict it, but I think you'll be interested to see these maps. Secondly, that what a lot of growers are seeing around the world are these abrupt changes in the seasons and how they are disrupting olive growing that we have known to do for so many centuries and millennia in the world, particularly here in Greece, and some of the strategies for adapting to this disruption. And then I'll talk about what we can do basically in very simple terms on some of the strategies that are being looked at worldwide. So of course, climate change is here. And a 2-degree increase in the temperature of the Mediterranean basin is widely considered to be a reasonable estimate of what you're going to be experiencing here, where, of course, most of the olives in the world are produced. And they're going to have a lot of impact on various crops. The impact, you'll be happy to know, on olives will not be as severe as some other crops, such as grapes and grapes and wheat, which are less drought tolerant. And it's one of the blessings of this crop that it is drought tolerant, that it allows it to survive in difficult conditions. And there will be winners and losers. Anytime you change the status quo, some people benefit and some people don't. And so you'll see that as we go through these maps. The model that I'd like to show you that these maps were derived from is called a physiologically based demographic model, which captures the weather-driven biology of interacting species. So these models are getting quite sophisticated. And this particular model has predictive value. It's been shown to have some good predictive abilities in other crops and ecosystems, and it doesn't have a problem with transferability to other crops. So the maps I'm about to show you will assume that greenhouse gases will be increasing, and we take a scenario that's sort of a mid-range in the Intergovernmental Panel on Climate Change list of 40 different climate scenarios that they've used in their projections. And we're assuming in these maps that there will be a temperature increase of 1.8 degrees centigrade in the Mediterranean basin, which we can expect to start occurring within the next 20, 30, 40 years. So within many of our lifetimes. So right now, here's the distribution of olives in the basin in red. You know, looking right around the water and in various areas of the water. North Africa, of course, various areas there, much of Italy, in Greece, you can see, and you know this area much better than I do, all the areas that you see in Spain, of course, the largest volume of olives produced in the world. So here's one of the first predictive maps for the future, and looking at the change in the bloom date, and this is in days, and you can see all over the map that the bloom is going to happen sooner, and perhaps you're already experiencing that now. And the range is from 3 days to up to 18 days, and the midpoint is in the range of 10 days where it goes a little bit white there. But in Greece, you can see you're more into the yellow and to the red, and so you can expect earlier and earlier bloom dates here in Greece, which in some ways might be a good thing. So now looking at olive yield, here's what was observed in 2000 in tons per hectare. And in the blue shades, it's under 2 tons. And getting into the yellow and red shades, it's more than 2 tons. In Greece, you're looking at more than 2 tons per hectare in much of the region, and quite a bit more in some regions. There's a part of Egypt that is in deep red, and they benefit from irrigation and a higher yield. So here's the projection of the change in olive yield that you would see in the future in tons per hectare. And in the blue shades, you're ranging from 0 to almost a half-ton less per hectare, which in Greece you can see some areas would have that effect. In some of Italy, you also see that effect, and in parts of North Africa. But in much of the area of Greece and many areas, you see it's yellow to red, which shows that there actually would be a net increase as under these projections. So that sounds pretty good. There will be some increases for some. I think overall the total volume is not expected to change. It's just going to be shifted in these projections. And then this study in particular was looking at the impact of the olive fruit fly and determining a number of things by the behavior of the fly. And with warmer temperatures, you can drive the fly out of the area if it gets too hot. And what we're seeing here in this map is that in the blue shades, you're going to see less of a fly abundance in the groves. Most of North Africa and Andalusia and Portugal, Sicily, southern Italy, in much of Greece, less abundance of the fly. And then in terms of the amount of fruit attacked by the fly, you're going to see a decrease in many areas in blue, including here in Greece. So this is in percentage of the fruit, and if it's in the blue shade, it goes from 0 to minus 42%. In the yellow to orange, it may go up to 33% more fruit attacked by the fly. So again, this for many people might look pretty good as a projection for Greece. Italy is going to suffer from more fruit attacked by the fly, and particularly in the northern regions as it warms up and becomes a nice hospitable environment for the fly. Then getting down to the bottom line, looking at the change in profit per hectare, euros per hectare, with 0 to a loss in blue and from 0 to a gain in yellow to red. You do see quite a bit of areas in yellow and red, which suggests that actually some profitability is going to go up in the future, but there's certainly some areas in deep blue that are going to suffer in the Middle East in particular. And what this study is indicating is that the decline in the Middle East may be up to 80%. So it's going to really suffer in their production. In Greece, it's more of a mixed story. Some gains, some losses. Here's another way of looking at this data. And you can see in that third one down with the Balkans, Greece, Turkey, and Cyprus, there's quite a bit of gain on that graph, but there are some areas that lose, and for those areas that lose, it will be painful. So, in summary, what you're seeing in this set of maps is that there's going to be some winners and losers in the future according to these projections. Of course, things can change. We're still in uncharted territory here. But they're looking at some high losses in Greece, particularly on small farms that are rain-fed, that are prone to desertification. And so we're looking at maybe 23% of the area of Greece that would be affected here, and you might just see that olive production will go away in those areas, which would be unfortunate and tragic, particularly with some of these areas having done it for so long in their history. But there's going to be other areas that will gain, according to these projections. So that was the first part of what I wanted to show you, is just a broad view of some projections which were designed by an international team. Part of the team was from Italy, and one member of the team was Andrew Paul Gutierrez, who's a professor at the University of California at Berkeley, who's done quite a bit of work on projecting for olive fly and climate change. So the second thing we'd like to just cover briefly are the seasonal transitions that many of us are experiencing around the world. I expect that you're seeing a bit of this here in Greece as well. And historically, the olive management was done by calendar. You sort of expected year after year that you'd have dates and milestones for different phases of development of the fruit. And so you'd have the bloom by a certain date and flowering by a certain date, pit hardening, the fruit set, etc. But climate change is disrupting all of this, and the calendar really is getting thrown away with a new set of expectations that we cannot necessarily predict by date. So let's go through each of these seasons and just some of the things that are going on. And we're seeing this in places in California and other places around the world. So summers, prolonged, hot, and dry. And overall, I found a study that was projecting for the Mediterranean region that irrigation is going to need to increase overall by about 18%. There's going to be more evapotranspiration as a result of more irrigation, and that'll go up by 8% overall. But one of the net effects of all this is there'll be an increase in the salinization of the soil, which long-term is, of course, a problem, and we would want to try to avoid that. So the other thing you get with less water and drier conditions is particularly with table olives, is smaller size, and growers are paid by the size oftentimes, and less quality in the fruit. And as we learned in those previous set of maps, some areas are not going to be really suitable for olive production anymore if they're rain-fed due to this summer heat. In the fall, more problems. Erratic behavior, early freezes. We're not just going to transition gradually into the fall with cooler weather, but sometimes you might have a period of warm weather and then a sudden freeze, and your fruit, which was doing so nicely right before harvest, is damaged and becomes unmarketable. So these rapid heat spikes also affect the dormancy accumulation and helping that tree enter into dormancy, and it creates some problem with less bloom and fruit down the road in the next season. In the wintertime, less rain, sudden freezes. You might have some rather moderate winter temperatures. Suddenly your trees get hit with a freeze and it's disrupting them entering their dormancy. You get tree damage, defoliation, and sometimes it just kills the tree. This is a picture actually from the state of Florida in the United States, which is attempting to find an alternative to the devastating impacts that they've had with citrus greening, which is, the last I heard, has destroyed about half their crop in citrus, which has long been a big crop for Florida. And so you're going to see problems in these areas, but it's not just in Florida, it's happening in California with more moderate temperatures. We're seeing these sudden freezes and we're losing trees, or we're really hurting our production. And then going into the springtime, such a critical period when you're looking for that next harvest. And you can get sometimes, as you're transitioning from the wintertime, you can get these heat waves that disrupt the bloom and may dry out your blooms. And you may then also get an abrupt frost and rain that prevent the pollination during the bloom. High winds are something that we're seeing quite a bit that are preventing pollination and leaning the tree over to one side in some areas. So problems in every season that we are finding in olive production. So the third thing I'd like to discuss in just very basic terms are some adaptation strategies for this disruption. And I'd like to cover a few areas here. One is to just adapting in the short term your current production practices, to secondly monitor the climate and your trees and fruit, and thirdly to consider planting better adapted trees, even if you've had certain varieties that have traditionally been part of the landscape in your region. So one main thing I just like to talk about in adapting current strategies, and this will not be an option for many if they don't have access to irrigation water, but to deal with the drier conditions and the threat of salinization of the soil, you need to irrigate more. And the irrigation is going to help flush through that root system the salt down below so that it doesn't have a detrimental impact on the tree. But you're also going to need more water to get the productivity on that tree and to get the fruit size. So, of course, this is not a solution for some, but if you have irrigation water, you'll need to use more of it. On monitoring the climate, like I said before, you'll need to change this farming by the calendar. You'll need to start collecting data and approaching this more scientifically with the use of that data. Now, collecting data can be a burden. You know, it takes some effort, and you have to be a good record keeper. But what it does allow is for you to determine if there's any trends and if things are changing. And so you'd want to record record data on the temperature and the daylight and the precipitation, the wind, the chill accumulation, which means basically that you're looking at the number of hours that are less than about 7 degrees centigrade. You need those chill hours, a certain number depending on the variety, to enter dormancy and then accumulate those hours so that you can ultimately break dormancy and get a good crop in the next year. So that's good information to have year after year after year, and not just going by the dates on the calendar. You'll also want to keep the phenology records on the dates that your tree is starting to bloom and flower, and then the fruit set and the pit hardening, and then the size of the fruit. You want to look and compare year after year as to when these dates occur and see if they're those dates are occurring earlier and earlier. Now there's some methods for doing this. It's sort of an old-fashioned method would be to record it on paper and just making a note with the temperature and the daylight and so forth, hours of daylight. But there's also more modern methods, and these things are going to get easier. And there's quite a bit of innovation happening in the agricultural sector. So this is a system that you can purchase and set it up in your own orchard so that you don't have to rely on some remote weather station. You can get it site-specific to your own microclimate. And it'll be a data logger that you can then download into your computer, and you can keep track of your records much more easily. And this is one system, but I'm starting to see many more simpler systems available and trying to get introduced in the market. And as these systems get introduced, they're going to become less expensive. And so if you have a smartphone, you'll probably be able to track on an app what's going on in your orchard in the future quite easily. So don't be discouraged that this is too sophisticated, there's too many calculations. Increasingly, this is going to become more accessible. The third thing that we can do in adapting is to look at trees that are going to be better suited for this changing climate and the changing conditions that we're seeing in our olive groves. So one way to do that is through accession, where you just bring in existing varieties that you've looked at the data on these varieties and they already are out there, and you think this might work in my conditions. So that's easy to do. It might be that you're getting a variety that is better, more widely planted in Italy or some other place, but whatever. It's going to take some new thinking to adapt to these new conditions. Another way to approach the changing of the tree that you have is through traditional breeding. And you're crossing two varieties that have the qualities that you're looking for. You cross them and see if that new variety actually is going to work. And there's quite a bit of, and the most work on this is being done at the University of Cordoba, where they've had a over 20-year breeding program that's been going on, primarily to look at higher density production of olives that could be mechanically harvested. They're doing that both on olive oil and table olives. But look to Spain for this type of work, because it's quite difficult to set it up in your own region. It's long-term work. It takes quite a while and quite a bit of investment to get results. At UC Davis, our industry in California is not large enough for us to justify having a parallel breeding program, so we look to Cordoba for the work that they're doing, and we would be willing to bring their new cultivars in to plant in our area to see if they would work. A third potential approach to getting better adapted trees is through molecular techniques. And we're going to hear some later on in the conference about what's going on in genomics in the olive sector. And of course, genetic modification is a controversial issue with many. But I think in the future, many of those who are now opposed or feel concerned about genetically modified crops may alter their thinking if the only way to adapt to climate change is through this method. Maybe the existing cultivars that we have are not going to do the job for us. We need to speed up the pace of change. We don't have the luxury of waiting 20 years, 30 years, 50 years for there to be a new variety that we could plant that's going to be a productive and profitable crop. And then an extreme option here is, of course, changing locations. If it's not working in your area anymore, you may have to move where your orchard is going to be located. That's not an option for many people, but that is an option that I think people will need to consider in the future. So to sum up, climate change is going to create winners and losers. We saw those maps. We saw how things shift around. And if you're in the winner circle, that's great, but if you're not, it's tragic, and you'll have to find other crops, or maybe there'll be some new tree varieties that will work for you. The seasonal transitions are becoming more ragged. We're not getting these smooth transitions that we've been accustomed to in the past, and we're dealing with very abrupt changes that are going to require us to adapt. We need to manage our irrigation to decrease salinity and to help the tree get as productive as possible, and to keep profitability up. We'll need to develop and incorporate into our daily practice out in the grove record keeping, which will become easier as we get more innovative solutions coming out of the private sector. And we're going to need to choose and breed cultivars that are going to help us adapt to the new climate conditions. And a lot of this work is already going on, whether it's allowed or not, it's happening around the world. So that's really what I wanted to cover here. And I think what we're looking at with climate change is that there's going to be disruption, there's going to be adaptation, and there's going to be some solutions. And the Greeks are really good at coming up with long-lasting solutions. We're inspired by the work that you're doing, and I'm looking forward to hearing the presentations of all the work that you're doing. We really feel the spirit of innovation happening here in Greece. Despite all the difficulties, what I have known from the Greek people is that they don't quit and they fight on. And so we're looking forward to hearing about how you're fighting on in the olive sector. Thank you very much.